Hi everybody, and thank you for coming. I'm the EDI SINOVC IC. I'm going to talk today about Hyperledger Fabric in particular and about permission blockchains. Why I mentioned and why I've written on the title that it's blockchain of future, because it has long-term support and solutions like that could be used for private purposes. But first, let's start with the basics. So currently we have two we have public networks and we have private networks. So for example, we can use Ethereum mainnet, or we can deploy our own private Ethereum network on our cloud on somewhere like that. And what else we have is that they can be permissionless or permissioned. So if Ethereum, like when we deploy a contract on Ethereum network, public network, they are usually permissionless. So you don't need any permissions to access it. You can read, you can write, and stuff like that. On the other hand, we can deploy contracts that are permissioned. So for example, we can use it for KYC purposes. Only people who have gone through KYC process, know your customer, so can participate in the process. For example, STOs and stuff like that. So one of the examples is the whitelist contract. So usually when we do an STO security token, only wallets that are listed on the whitelist can access and can trade these tokens. So this is an example from OpenZeppelin library where you can use roles for something like this. There was revolution or evolution of tokens, or ERC20, anybody could trade those tokens and anybody could buy it and sell it. And now we have this new standard. What is important is those are two different topics and two different problems and solutions for those problems. And what in particular is interesting here, that ERC 1400 has a ERC 1644 that is controller token operation standard. What that means is that there is an admin that can revoke your STO tokens from you at any time if it's necessary. So we've gone from completely permissionless ERC20 tokens that you control to the STOs that you have an administrator that can take those tokens from you. So we've gone back to the banks, let's call it like that, but to be by the regulations that we have in this world that are more open but still not there, we have to implement stuff like this. So it definitely would be awesome that we could trade stuff like this, but the market and regulators are still not there. Like Polymath is an example of a platform where we can create those STOs. You can use main networks, public networks for this, but there is a lot of data and the congestion on Ethereum is quite significant. You know all about CryptoKitties problems and the usage and what happened with that. And there are some hybrid solutions that are then used. So we can have, let's say, transactions, only payments on the mainnet, and all the data stored on a private versions of the network. So we have data and transferring of assets, stuff like that on private networks, on private blockchains, and transfer of tokens and some crucial stuff on the public network. These are some of the examples, some of the most used examples out there, the technologies that are used for private solutions. Of course, you can use Ethereum on proof of authority for local, private blockchain networks. Why proof of authority? Because proof of work on a private network with a low hashing, and it's not good because it's vulnerable. So we use proof of authority instead of that. So we have trusted nodes in this setup because those data it's not that crucial as the transfers that we do on the public network is. So we are somewhere in between to do that. Another solution is JP Morgan's Quorum. The difference between Ethereum and Quorum is that we have private and public world state on Quorum instead of just public world state. So it's one of implementation of it. Hyperledger Sawtooth is quite interesting project because it uses both. So proof elapsed time is a consensus that is based on Intel chips So it works like this. So you have an Intel chip. It randomly generates a time that that process sleeps, and when it wakes up, if it's woken, it can write to the blockchain data it validated through the contract. So we don't know the time when that process will wake up, so we can't predict which block we will mine and put into the blockchain. Of course, this has some side effects, and there are it is in development, so there is a lot of stuff to do in the future, but it's quite interesting. Also, we have something very, very specific. It's Corda. Usually on blockchain, we have gossip protocols, we have world state and stuff like that, but on Corda, we don't have any of that. So we have local states, we don't have gossip. If you want to transfer data to somebody else, you have to send them yourself. So if you want to transfer data from node A to B, you have to do it yourself. There are implementations in business. I haven't used it in my implementations, but it's definitely interesting choice and interesting technology, and I'm open to what the future holds for it. About the Hyperledger Foundation and how it was founded and by whom. So the Hyperledger Foundation, under which Hyperledger Fabric is a project under Linux Foundation. As we all know, there are a lot of interesting projects developed under Linux Foundation, like Node.js, like Let's Encrypt, Linux itself, so like GraphQL and stuff like that. And it's quite the Linux Foundation is open source based foundation that supports this kind of project. So all the projects on this Linux Foundation are open sourced, and the Linux Foundation provides PR and marketing stuff, but doesn't provide financing. This is a scheme overview of the Hyperledger Foundation itself that is on the Linux Foundation. And the project we are going to talk about today is Hyperledger Fabric. There are the solutions like Hyperledger Indy that is quite promising in this decentralized identity area. And I think that it will be quite interesting to see what it brings. The idea of Hyperledger is to have a standardization. So in Ethereum, still we have a problem with a lot of beta versions and stuff like that. Until we reach Ethereum 2.0 with the proof of stake, and until we manage to scale it with sharding and stuff like that, that's like we had a presentation before, we need to use some kind of these hybrid solutions that could solve a problem of scalability. So now on to the Hyperledger Fabric itself. In base, all blockchains are distributed databases. So it's a distributed database with specific rules and specific attributes. In this case, Hyperledger Fabric, it's permission. That means that you need to have permissions. You have to go to some KYC process. You have to have certificates that are issued on this platform to be a part of a platform. So that's what it means that it is permission. Also, we have multiple channels. I will talk about it later. It's similar to side channels, what Ethereum 2.0 wants to do with the side chains, sorry. And of course, we can have private data. You can encrypt data and store it encrypted like that on a blockchain so nobody can read except of you. The most important stuff, it's a LTS version is up there. So we have support for next 2 years to use this technology. It won't change. And for businesses and business development, you have to have technology that is stable and that you can count on in the next 2 years or 5 years and stuff like that. Because usually when clients approach me, they ask me, okay, this is awesome, but how do we know how it will change? We'll have Ethereum 2.0 in 2 years, in mid-2020, and what then will happen? Will they manage to deploy a new version? What will happen with the old or migration stuff and like that? You can't plan a business on it. That's the main problem here. So we are in some mid-phase that this solution wants to solve, wants to take a part of the market share by providing long-term support to the. What is another feature that they are proud of is that you don't need to use new language. You don't need to learn new language like Solidity is, but you learn languages that are out there and that are widely used. So you don't have to teach developers new languages, new paradigms, new ways of thinking. You just use JavaScript, Golang, or Java, and you implement in them. So it's not quite different from classic backend development, stuff like that. There are some specific rules, but it's quite similar to that. Also, they have developed something similar to Web3. It's called Fab3. like interesting name to use for that, but okay. It's also written in JavaScript, Java, and Python, so you can choose like the language of your liking. Now I'm going to talk a bit about consensus on it and architecture overview of the solution. So first, when you start developing on Fabric, you use Solo. It's only one order. It's for development. It's not fault tolerant, so you don't use it on production solutions. On production, you use Kafka. So how many of you have heard about Kafka here? Okay, awesome. So like you have something similar to Kafka. You have leader-follower model, and you have a zookeeper that is that you have a backup of those data, not to get into too much detail. And what is the advantage of it? What was released as like last month was the Raft consensus, which implements that all in one service. So it's not, you know, currently you have orders, you have Kafka, you have Zookeeper, those three services, and it's not quite working that good because you have three services that can fault any at a time, any of them. So implementing that all in one service is definitely a good step forward. This is the high-level Hyperledger Fabric overview. So on the left side, we have a client application. So you have a user that doesn't know that he uses blockchain. So you have some SDK, you have some classical backend that communicates with the blockchain. We have a message service provider, which is certificate authority in its core. So you have certificates that are given to the user, and users have to use those certificates to communicate with the blockchain. If you don't have a certificate, you can communicate with the blockchain. Peer is the most similar what like Ethereum node is. So the peer has a ledger on itself. So the peer has all the data, all the events, all the state on it. And we have an ordering service that is responsible for adding that data to the blockchain. So how, like, we are going to go through a basic use case here, how the user will interact with this system. So the client application would like to add some data to the blockchain. So they sign that transaction with their certificate. They send it to the peer. Peer then endorses that transaction. So the peer reads current world state, does the smart contract, calculates what's the world state after it. It doesn't write that to the blockchain. It just endorses it and returns it to the client. Then client captures all those endorsements. Let's say if we have 10 peers, we need at least 3 endorsements from peers. And if all those endorsements are the same, then we commit that to all the peers, which are then committing peers, which then send transaction to the ordering service. Do you have any questions? It's quite complicated a bit, so if you have any questions, yeah, you just ask me.
Now or later?
Yeah, you can do it now, so we have a picture up there, so if you have any questions.
How many ordering services are there?
It depends. So in Solo you have only one, and on Kafka you can have many. So you have one that is leader.
At least one.
No, it's not connected to organization. Peers are connected to organizations, okay. And ordering nodes are just there for ordering. They are like message queues. You have Kafka, you have incoming peers are message producers, and orderers are message consumers. So they just order the transactions, so we don't have a double spend stuff like that. And we have only one leader orderer, and that leader orderer decides which transactions will be stored. It's trusted setup, so it's trusted. Those orders are trusted.
The order is trusted setup.
Yeah, the orders are trusted. Yeah.
So theoretically, can you have like every organization to elect one order and the orders to synchronize between each other?
Like it's randomly, like the order is randomly elected. So you don't know which order will be elected, and orders can change. So you can have some randomness you can have inside. So you can have order from one organization at the moment and then some other. So you don't know which order will be leading order in that moment. So that way we have pseudo randomness. Of course, the less the order nodes, the more predictable the system is. So that's definitely the problem with the private networks usually. So the less the nodes, the more vulnerable the system. So, but with this permission layer, we have only users, and we can recognize which users are harmful, and we can remove them from the system. Yeah. So that way we solve that problem.
Can I throw one more?
Yeah, of course. Yeah, go.
So the client application signs transaction, sends it to the peer that has to endorse it, send it to the order, commit it, and order is going to put it.
It's like client sends it to endorsing peer, endorsing peer returns it to client, and then when, let's say, 30% or 50% of the peers have endorsed it, then it goes to the committing peers.
What is the client? Is the client
backend, front end, like any classical? So you have a wallet, private key, you have a certificate, you sign a transaction using, like, let's say Web3. When you use Web3, you sign a transaction like using your private key, using your certificate.
What's the best practice for getting the certificate into your, let's say, website client application for your users? Is there any best practice there?
Yeah, like you generate a certificate, you place it on offline, you place it on the device, and then it's a hot wallet in Ethereum sense of hot wallet. So you have private key on that device.
But you will do it yourself with a hot wallet. You won't do it like with cloud-based.
You can do that also. You can store it in a cloud-based solution, but then you store that private keys on a front end, on the service you held. It's not on the user side. So that's a security risk. So you can store keys on your backend, on your front end, but how much does it make sense to store user private keys on your, you store it on your system, and you can use it. Yeah, one user is associated with one organization.
So if I'm like the admin of the organization, maybe that it makes sense because the user like.
Okay, definitely. But then again, how to prove a user can ask, okay, I didn't do that, and how you can prove that you didn't do that, because you have, on a blockchain, you have a transaction that is signed by that private, that certificate, but we don't know where it came from. Like when we look from the front end, from the blockchain standpoint, we have a backend service that has private key of users. Like it can be malicious. Somebody can penetrate backend service and can use and sign transactions on behalf of those users. It's the same with Ethereum. If you store like private keys of users on backend, then it's a security issue. So.
It has pros and cons.
Yeah, it depends, like what you need. If this is an application that we use blockchain for the backup or as a feature, so users don't know that they are using blockchain. They have like, let's say, just a plain username and password, and we sign, like we do something, store those keys somewhere in some wallet that is like hardware wallet or something like that, then we can use it like that, definitely.
Let's continue this up.
Yeah, okay. Yeah, we can talk like, yeah, you go.
What happens in the committing phase? Is that when the consensus happens, or?
The consensus happens on order. So the committing peer takes his world state, does the smart contract. So it goes to smart contract and signs on the output of those. So the current world state, the end world state after the chain code that the smart contract was done, and he signs that and sends that to the orderer. So what can happen is that we have like committing peers with different they are not all in sync. So we can have some peers that sign transactions that are not up to date, all up to date. So we can say that 7 of 10 peers, let's say committing peers, has signed that transaction and sent that to the orderer. Then orders those transactions and validates if enough committing peers have said, okay, this transaction is okay, and it can be done.
I thought they were the endorsers.
Yeah, they can be endorsing and committing at the same time. So yeah, it's
not like you submit the transaction, you wait for endorsement, then you send request, wait for endorsement, you send another request for
committing, and then yeah, you have a smaller amount of peers that are endorsing your transactions. So we avoid committing at the start. You don't commit to all the peers at the start, but you just do on a like some small part of them that are endorsing peers. So they can be endorsing and committing at the same time. Like it all depends on the, yeah, it's quite interesting approach. Like you have endorsing phase, you have committing phase, and then you have orders that are ordering, and orders are storing that to the blockchain. And they are responsible for then broadcasting that new state to the peers, which then change the state of the blockchain. Yeah, it's a bit complicated at first, so yeah, definitely we can talk about it. So yeah, like endorsing phase, I think it's for preventing the spam attacks. So yeah. Okay, do you have any more questions? Okay, let's go further with this. So we have another like logical idea behind this is our channels. So the channel is most similar thing to sidechain. So they are logical, they don't exist in reality, but what they are peers from different organizations that have copy of the ledger. So let's say on sidechain, like on this channel here, on this sidechain, we have peers from organization A2 up there, peer 3 and peer 5 connected to that channel, and they have a copy of that channel. Also, peer 1 has copy of the ledger of that channel. Peer 2 doesn't have a copy of that channel. So organization can be part of a channel, but all peers of that organization don't need to have a data from that channel. So okay, we can reduce amount of redundancy, but again, we can add all peers, or we can like lower the amount of peers that have the whole copy of it. So it all depends, and it's quite flexible in this sense. And Fabric has aimed to be quite as flexible in this as possible. So I hope that's okay. You have one main channel at the start, so all the organizations are part of one main channel at the start. Let's call that the main ledger, and you have separate ledgers later that you can connect only some organizations, stuff like that, and you get privacy by doing that. So these are MSP and the overall like architecture of authenticating the users. So we have a client organization, like we have a backend client that communicates with the blockchain. The client sends the transaction to the peer. Peer then asks MSP, which then communicates with the certificate authority. So MSPs are connected to one channel. We have like MSP for each channel for each organization. So yeah, it's a lot of moving parts. But yeah, like the other idea could be why they didn't just implement it like, okay, we have a peer, it communicates with the certificate authority and returns like, okay, this user is part of a system, can access this data or can't. So that was the other idea, but they solved this using MSP providers. So you have like communication between certificate authority, MSPs is only done on this channel level. Like MSPs is for channel, then it communicates with certificate authority. Do you have any questions on that? We can cover that later. And this is like architecture of the solution with 2 channels and multiple organizations. So up there we see that peer 1 is connected to the channel 1, peer 2 is connected to channel 1 and channel 2, and peer 3 only to channel 2. So in this case, we have a ledger 2. So ledger 2 is a ledger from channel 2. Ledger 1 is a ledger from channel A. And we have smart contracts. So smart contract 5, smart contract 6. In this case, peer 2 can access the data from both channel 1 and channel 2. And peer 1 can only access channel 1, and peer 3 can only access channel 2. So we have separation of that, and only if organization 2, peer 2 is from organization 2, only that organization can access both channels. So in this case, if we want like some data from channel 2, let's say we are selling some product. So organization 2 is selling some product to party A, to organization A, and to organization 1 and to organization 3. Like organization 3 can see what the price was, what was offered to organization 1, and vice versa. So we have privacy in that sense. We have separation in that sense. On the public networks, you have like, it's all on the one ledger, one on Ethereum, it's all on one ledger, and you have all data there. Okay.
Channels like Ethereum, let's say channels where everything that happens is kind of off-chain, and then after the channel is closed, it goes on-chain.
No, it's like channel is just logical sense. It's not like, it all happens like the channel is just a ledger. So it's a separate, like a separate blockchain. So you have multiple blockchains. One channel is one blockchain, let's call it like that. So they are completely separated. And it's on, like everything is done on-chain. Like every change, every commit you do, if it's written in a channel 1, it's in that ledger. If it's done, it's written on the blockchain. It goes through that process, and then it's written on the blockchain.
The channel is
different blockchain, different ledger. Completely different, not connected to one another. So we have multiple blockchains multiple ledgers on this. Yeah, correct me if I said something wrong. Also, the stuff you can do is access control rules on the network level. So we have a network. We have network configurations and channel configurations, and on that side we have granularity based on the channel-based access and on network-based access. So we can like filter DDoS attacks from outside. So if somebody comes without a valid certificate, we can remove them at the first phase of the attack, like at the base of the attack. The idea, of course, in the end, like these are private solutions and it's okay, but they are vulnerable because there are a small amount of nodes, and it's, you know, the small amount of nodes bring a risk with itself because it's easier to hack those nodes. And the way we solve that is using interoperability. So in this case, they managed to do interoperability with Stellar. Like, what you think about Stellar is your opinion. So I'm really not like it's all about like your personal like opinions about what to think and not to think, like Ethereum to use or you use Stellar, stuff like that. But what is interesting about Stellar is when you commit, when you create a transaction, you get the URL in classical web URL, like you can get request with some ID, and you can send that to the Hyperledger Fabric smart contract. And then the smart contract can wait for that to be, you know, when it is done, like when the transaction is transferred, assets on Hyperledger Fabric can be transferred. So that's the main advantage of using something like this. Of course, like in the end, Hyperledger Fabric is not an exchange. It's not. We are not removing Ethereum from equation. Definitely, Ethereum is the most developed currently, but we have some solutions that are hybrid here and that are in development. And until we reach Ethereum 2.0, it's definitely a matter of like which technologies to use for this. If you have any more questions, yeah, you go.
Channels created between nodes, and you can create a network where I disable all channels and there's only one channel.
Yeah, of course. You can have only one channel. Like when you create a network, you create one main channel, one main ledger, and all the peers or the organizations are part of that channel. And then you can create separate ledgers. Okay, you can separate channels.
Channels are communication between nodes.
Channel is a logical thing, so like, yeah, ledger between two nodes, so or multiple nodes. So peer is one node, and organization can have multiple nodes. So we can have like, yeah, it's a ledger between nodes, two nodes, more, three or more nodes. So it all depends how many nodes you connect to that channel. You don't need to have. Like you can have your node if you have your organization that is part of this network. If you are a company, you have your nodes. That is the idea whole. That we have multiple companies, like consortium-based. This is a consortium-based blockchain. We have multiple companies, and every company has peers, has nodes in this network. And depending on which channels they are connected to, they can see the data that is on that channel. And that channel is actually nodes with the ledger that is the same on those peers. So we can have a separation in that way. We can have sharding in that way. Yeah, any more questions?
I have three, but like...
Yeah, okay. Yeah, you go.
We have distributed relational database for almost 30 years.
Yeah.
We have Byzantine fault tolerance for almost 40, 50 years right now. And how is this different?
Yeah, like this is a distributed database that is immutable and that has a permissioned layer. So you can use a database like classical database we did, but you on a classical database, like what is added security of this is that immutability. So you can't delete data from it. If you can't delete data from it, then all the transaction, all that is done on this system is written, and it's written in this system. So one of the use cases could be, let's store just hashes of logs on this. So it doesn't need to be crypto, it doesn't need to be finance. It can be like a backup storage of some kind, but it's immutable. You can delete from it, and that's what added extra security to it. Yeah, you go. Or if there is anybody here, out there. Yeah, we have 1 minute, so.
I'll throw you 3 questions. You answer them in 10 seconds each.
Okay.
Like, based on what you say, it's how do you, okay, first question. How do you add new organizations post the creation of the network?
So the current organization have to agree to adding another organization. Well, relatively easy.
How do you make it? Do you alter some YAML files?
Yeah, something like that. Something like that. So you deploy new certificates and stuff like that.
Do you add a new peer to a channel, and does they see the old history of the channel?
Yes, they do see all the history, and you add it to similar. Like you create a new peer, and if that peer is a part of an organization, you can connect that peer to all the channels. You can, okay, say this peer connects to these channels in this, and it's all written on YAML or stuff like that. So when you deploy it, it connects to the current channels.
Everyone on the channels needs to agree for this peer to get into this channel.
Not because, like, if organization is part of that channel, then peers automatically can be added. So yeah.
Theoretically, I can create a new organization, create a new peer, and for the organization to get, every other organization needs to say okay. And then for one of my peers to get into the channel, nobody has to say okay? Or?
Yeah, because if you are part of a channel or as an organization, so you have organization here, then you have right to add new peers. It's just another copy, another node running in this, says.
So you can be, as an organization, can be added as just in the channel, but not the main channel?
No, you have to be in the main channel. Yeah, at the start you are in the main channel. You can probably change that. You can remove organization from main channel. But at the start, all organizations are part of a main channel.
Is there like a record that says, hey, now is when this organization gets added for all the integrity?
Yeah, it's all. They are all like transactions that are written in the blockchain. So usually, like what we use underneath this are CouchDB or LevelDB. So every peer has CouchDB or LevelDB that is like applied, that is changed, that it can be deleted from. So you have like classical NoSQL database that every peer has that has all the data inside. So you can delete from that.
Okay, cool.
Yeah, okay, thanks.
Should we wrap it up?
Yeah, thanks a lot. If you have any more questions, yeah, thanks a lot.